Alright, for number 6, we're given secant times sine minus 3 sine x. And again, you might think you want to try to change something so that they all become the same trig function, but it's really unnecessary because we can already factor it the way that it's written. Alright, so if you look, both of them have a sine x in common, so that's what we're going to factor out. So we're left with the secant x minus 3 is equal to 0 because both of those sine x's got factored out. So sine x is equal to 0, and secant x minus 3 is equal to 0. Alright, so for the first one, sine x is equal to 0. That's going to happen twice on your unit circle, and they're both going to be at quadrantal angles. For the secant one, so we'll need to solve it. So secant x is equal to 3. And remember, the best way to answer the reciprocal functions is to, instead of thinking of it as where does secant equals 3, which we're not as familiar with the secant, cosecant, and cotangent values, ask yourself instead, okay, we know that secant goes with cosine, and we're going to then take the reciprocal of this as well. So really the question you're going to ask yourself is, on the unit circle, where does secant, or not secant, cosine equal 1/3? And that's not going to happen. So this part of this equation is not going to give us a solution. Doesn't mean that there's no solution overall, it just means that that factor, that secant x minus 3, does not give us a solution. So if we go look at the unit circle, we're looking for where sine is equal to 0. So we're looking for where our y-coordinate is equal to 0. So we see it's happening here at 0 and at pi. So when we go to write the general formula, we'll to keep that in mind. Alright, so x was equal to 0 and pi. Since these two angles create the same line on the unit circle, we're only going to need to keep the small guy, so 0, and add pi k to it. So x is equal to 0 plus pi k. That's your only solution for this equation.
Made with Doodlecast Pro.